Thank you. I was promised fire. I thought this was going to be a fireside chat.
A fire, yeah, where's the fire? Where's the wine? Didn't you sign a contract that said you drink chocolate wine?
I've been drinking it all morning, but I don't understand the context behind it. I just feel weird now. What is the deal with Chocovine?
Chocolate wine is just a pure delight. It's a dessert wine mixed, it's basically Cabernet Sauvignon with a blend of Dutch chocolate, and you mix it together, and that's it.
Is it good?
Let's move on to the next presentation. Bob, I believe, I'm going to give you a quick introduction. You work in a Dart team at Google.
I'm at Google.
You're like a VM hacker or language.
I'm not a VM hacker,
What are
but
you?
there are a bunch of VM hackers there. These days, let me tweak this a little bit here.
Yeah, no worries.
Used to be in a band, so now I am highly tuned to how is the audio. I work with a bunch of VM hackers, but my job these days is working directly on the language design itself. So I'm writing proposals for new language features, trying to evolve the language to make it better for what our users want. My running joke is that I'm a markdown engineer now because that's what I write the most of. I've been on the team a long time. I used to just be a regular software engineer on the team, so I was one of the co-creators of our package manager. I wrote automated formatter, some of the initial kind of core libraries and packages, that sort of stuff. Which, if you ever get the chance to do that, it is super fun to do greenfield development of like a brand new programming language that has no ecosystem. It's like, oh, I need to parse command line arguments. No one's done that before. It's like, I get to write the first library for that. It's really fun.
That's awesome. And I think you also, not too long ago, wrote a book.
I've written two books.
2 books? I did not know that. Okay, let's talk about those 2 books for a bit.
So the first book I wrote is this book called Game Programming Patterns. It's kind of like,
Yes.
it intends to be sort of like design patterns for game programming. And wrote that close to a decade ago, which, man, that sounds like a long time. And then after that, I wrote this book called Crafting Interpreters that is about kind of designing and implementing programming languages from scratch.
I want to ask our moderator to post the Crafting Interpreters link on the chat.
It is craftinginterpreters.com, which is hopefully fairly easy to remember.
Yeah, it's an excellent domain. So that's interesting. And this is where I want to start because something that happened in this conference is I did actually a language hiatus. I did a language hiatus, which means that people who do give talks usually about a programming language, like, hey, I made this new language, I want you to maybe check it out and adopt it. I did do a hiatus this year. I don't know if that's going to make you angry.
I'm not pitching any language here.
Yeah. Well, and the reason I did that was because there's 2 things. I've noticed and we're going to get into this later, I've noticed kind of like a contentiousness around new languages. So you've had things like Rust spring up and become pretty big. You have Zig up and coming, and you have Odin up and coming, and you have all these new languages. And the communities, not the entire community, but fractions and factions of these.
You all are wonderful.
You're excellent
It's people not in this room.
Yeah, thank you for being
Or
here. No,
watching the stream.
No. And some of them are vociferous about, well, this language should not exist.
Yeah.
Right? Like, for example, your memory unsafe. You're unsafe, therefore you should not exist. It should be me. And then it spreads through like wildfire on Hacker News, on the Discord, on the Reddit. It's intense. Yeah. And somebody who runs conferences now, and I'm tuned into like social trends, I've noticed that this is just getting worse. I don't like that. And then the other thing that was happening also was I was getting like lots of proposals to like come talk at this conference from lots of different programming languages. That was like, hey, I have a GitHub, I want to start a sponsorship program, I have this language that just like targets LLVM, and it doesn't do much, it's just like a cosmetic change over this other language, and nothing wrong with experimenting with languages, nothing wrong. I encourage people to, make your own language and stuff.
Is this really just a criticism of Dart? It's okay.
I didn't want the conference to become like a boxing ring, right? Yeah. Where you have different languages saying, hey, come to, enjoy this talk, enjoy this language, adopt it, and then another conference speaker comes and says, no, come to mine, right? And especially with the viciousness that I've noticed from communities online and how they talk about which language to adopt or not, right?
Yeah, it's a real thing, right? Like people get angry about it.
I was going to say, so how do you feel about maybe this trend? Maybe it's always been here forever, but maybe it just feels more intense with social media or something. But
Yeah, it may be more visible these days. I think it's always been around. We dealt with it in the early days of Dart. We still deal with it. There's a thing where, people get upset when a language isn't what they wanted it to be, even though it didn't exist at all before and they had zero expectations. I think part of it, I try to be charitable in how I interpret the way people react to things, right? Because we are all basically just primates that are way above our pay grade 24/7. And my hypothesis for this for languages is that people are feeling the opportunity cost, right? So especially, when I work at Google and when a company like Google puts out a new language, you only get so many chances to do that, right? And people feel that really intensely of like, if that's going to happen, if one of those rare chances of putting a new, widely supported language out there happens and it isn't what I'm hoping for, they feel that is a loss, right? Like this is an opportunity that was taken for them. And I can sympathize with people being upset about that. I get cranky when languages come out and I'm like, oh, I wish why didn't they do that thing differently, right? And it's, they're just, languages are so weird in that there aren't that many that can get successful, right? Because what they need to be successful is a giant ecosystem. And there's not that many of those to go around, right? Like the way a language gets big is by lots and lots of humans dedicating fractions of their life and their attention to it at the expense of other languages they could put that into, right? So,
absolutely.
So I think it's somewhat reasonable for people to kind of feel territorial about it. I try not to be that way.
Right. Well, actually, it's interesting because this is why I brought you in here, because you did write a book.
Telling people to make lots of new languages. I didn't say they would succeed. I'm not doing a good sales pitch for my book right now.
Oh, it's interesting. Do you think people can learn? Because I would say this. You mentioned something about ecosystems being entrenched with these languages. And that's why it's an opportunity cost, like you said, because you've invested so much in this new language and this ecosystem and the libraries that go with it. It's like this huge island unto itself.
Yes.
That it's an opportunity cost, and you want to make sure that that's protected.
Yeah.
Right? So if you do see some new threat, for example, you're like, no, like, stay away.
Yeah.
Right? That's interesting. But is there a way, and I guess with your book, I'm interested, is there a way for people for programmers like yourselves, to build this skill, to build any interpreter, build any language without that huge complexity that comes with like a general programming language, such that it just becomes a normal thing for anybody to write a language, for anybody to write a compiler? We find a way to simplify the tech stack, we find a way to simplify the complexity. Is there a way to simplify this complexity? All of those things, right? What's your thought on that kind of stuff?
That's a lot of questions.
Yeah.
So
it's
can we make it easier for new languages to be successful? I think maybe the answer is that's just really hard, right? One of the things that I've observed, I've been programming professionally about 20 years, and one of the things I observe is that programming environments keep getting better, right? Like the experience of being a programmer. When I first started programming, we didn't have syntax highlighting, right? Like, and all of the tooling just keeps getting better and better and better, and that becomes table stakes for any new language to come out, right? So the cost gets higher. There's a benefit for that, right? All of us programming in these languages that have great tooling and environments are much more productive because of all that stuff. But it does mean that I think the barrier of entry gets higher. So, is it going to get easier to make a new successful general purpose language? In a lot of ways, probably not. In some ways, yes. It's technically a lot easier to implement a language now than it used to be. We just have a lot more memory. So, back in the day when you had to write a compiler that could compile without being able to hold an entire source file in memory, that was a harder skill, right? And now you can just be like, yeah, just parse the whole thing to an AST. We got tons of RAM, right? Yep. So in some senses, they're technically easier to implement. I'm really excited that there's tooling like what is it called? The language server protocol, which gives you an abstraction between the static analysis user experience in an IDE and a specific language providing static analysis information from that language. And having that API means that if you write a new language and you add LSP support for it, man, I hope I'm remembering the acronym right. Did I get that right? Okay, awesome. If you have a new language, you implement LSP support. Now any IDE that understands that protocol now has good static analysis support for your language. And that's really, really cool and didn't exist, it's what, half a dozen years old. So that kind of stuff makes it easier. But I think the biggest cost when you're trying to make your language successful is getting it into people's heads, right? And
mind share.
yeah, and people are like entirely rationally reluctant to do that, right? Like there is a real material investment cost in their time and attention to learn to think the way that a language asks them to think, and it's hard to get people to want to spend that, right?
Is there a way to consider maybe a mindset shift from all of this? Because I agree that things like LSP and all of these and IDE integration, all of that are methods of simplifying the process of making a new language. But isn't integrating into those things adding to the general overall complexity of the ecosystems?
Yes.
So I'm imagining perhaps, and maybe you think this is like La La Land, but imagine like if people shift from a different mindset, like they read your book, for example, Crafting Interpreters. Okay,
Always a good first step.
you're lowering, you're lowering the barrier of entry
Yeah.
for people to learn exactly how to write a tree walk interpreter or a VM and a language that would compile down to the bytecode for that VM. Anyway, you're like building muscles, building skills, so that when you see like a new language come out, maybe you say, well, I see that language is interesting. I also know I have the capability to write something similar, to write something like that, right? So it's like we're teaching people, hopefully, that writing a compiler, maybe writing a VM is something that anybody can do.
Yeah.
Anybody can learn, and you're lowering the barrier of entry with books like yours.
Yeah.
And then when everybody has that muscle of like writing a compiler is not that big a deal. Of course, writing one that's production ready and that's everything that everyone expects out of it, right? The LSP, the syntax, sure. But if somebody knows how to write something, then I think in some ways we've made things better because we've made things less heated because now you invested so much in this new language because it's the one you have to use. But if you know how to write your own languages, you technically, even if it never happens, you technically know you could write your own thing. And I think that, I don't know, gives you some maturity over the discussion of what's going on with languages. I don't know.
This is something I think a lot about.
Okay.
Just like when I think about what it feels like to live today, it feels disempowering in a lot of ways, right? Like I feel like I spend a lot of my time just reading the news and feeling like I'm this tiny little ant and there are these giant behemoths walking around that are billionaires or corporations or governments, and it's like I just want to live my little life and hopefully not get stepped on. And it's there's a reason that like lots of people have anxiety and lots of people are on anti-anxiety medication. And one of the things so you may not implement a programming language, a general purpose language that becomes wildly successful, but I think there's still value in understanding how things work and feeling that you can do things just to cope with that sense of disempowerment, to feel like, you know what, there are corners of the little world where I can make an impact and that I can feel that I have some mastery and some understanding. And for me, at least, that's really important. It's why I spend a lot of my free time hacking on programming languages that no one will ever use, because it just gives me a little corner of the world where I feel like, okay, this is a place where I can do things and where I can feel like I understand stuff. And that's valuable. Right?
Of course, that's valuable. Do you see a hopeful future because you mentioned like the incentives right now, I talked about that earlier, about the incentives that are like dominating everything and the corporations and the big companies and everything's like anxiety inducing. So you have that, we have the Handmade community. Like if you go to our Discord, we have like thousands of people in there. We have hundreds of people here. And it's like, it feels like a big community, but in the grand scheme of things, we're a really niche group of people here. Compared to, like, I believe in the United States, something like 8% are in IT, and sometimes these studies have different numbers here, but let's say something like 8% of people in the United States are actually in IT or in any STEM, and out of that 8%, an even smaller percentage are actually software engineers, and out of that percentage, even a smaller percentage are like decent quality.
Oh, shots fired!
It's the wine. So. If we think we can somehow rise above the overall trends of the industry that are making everything sucky, right? And software is a terrible experience for people, and it's like, do you see any hope and maybe making some changes, or do you think this is maybe like kind of futile, or because you just, the way you framed it is interesting, because like, yeah, it's disempowering, but if we do have more knowledge and we learn how to write things ourselves and all of that stuff, then we have some way to maybe have some kind of self-preservation. But is that all we can expect out of the future, just self-preservation for ourselves?
Yeah, it would be sad if the only thing that this gave you was a retreat, right? Like just a place to hide. I don't know. I try to be optimistic about the future. It's not an easy time to be optimistic about the future right now. I also try to be charitable about, there's a lot of stuff about software that drives me crazy too, and it's like bloatware and garbage, and I'm like, that's not the way I like to make things. But that software, even when it's kind of bloated and slow and crufty, is providing a lot of value to those users. Sure. And I wish maybe they had a greater range of options to choose from, so that maybe they could find software that's even better tuned to them.
We're going to see some demos today.
Yeah. But, it is making their life better. And I think, one of the things that, people like us, we're probably psychologically similar in some ways, that a lot of us are sort of naturally perfectionists and idealists, is it's really easy for us to just not observe the stuff that's working, right? And, there's a lot of bad stuff in this software, but like, we just take for granted all the stuff that works great. It's like, I got here, I took a lift, and it was like, I took 3 taps on my phone, and then like a driver magically showed up, got in the car. The driver didn't know where they were going, but like had navigation on his phone, and like all of this is magic, right?
I did get like a Big Mac last night in 15 minutes. Yeah. At the press of a button. So. And how am I skinny? I know.
And there's like, I definitely have concerns about giant corporations, one of which I work for, and things like that. But I think it's also good for us to just remember like how much like software is like actually pretty awesome. Even when the code is crappy, the utility can be pretty nice, right? It's also nice to have good, clean code in small applications too, though.
Code size, yeah. Well, we have some presentations here of people who think, and I encourage them to take entrepreneurial risks, let's say. Mm-hmm. So there are some people you're going to learn about today that are starting their own business, that are starting their own little companies and nonprofits, or their indie shops and all of that.
I admire that courage.
Yeah, it takes a lot of courage. I'm running a conference independently myself, and it's like, I
admire your courage.
For full time, and again, like without corporate backing, and just like everything in house and myself, and like so far so good, right? And I think people who care about software quality, who do start their own ventures and their own ideas, I think that could be inspiring. Yeah. And then maybe it could trigger a paradigm shift of some kind, like to say, hey, here's this growing number of people who put the quality of software as an incentive bigger than other incentives, and let's see how that plays out. Yeah. So that could be something, maybe. But in terms of what you've done with, again,
let's talk about me.
Yeah. Let's rewind.
My favorite subject.
Let's rewind the clock for folks, because you work on Dart, which is a high-profile language. I think it's because of Flutter, right?
Yes.
You have Flutter, which is
sort of our Ruby on Rails, right?
Yeah. Well, it's an amazing SDK, at least to target, I believe Android and iOS.
And desktop and web.
And desktop and web, just like by targeting Dart, you target those platforms right away, and you're part of that team. And again, you wrote a book that tries to lower the barrier of entry for people to write their own VMs and their own compilers. But how do you get there? Because it's interesting, because you wrote that book also while you're already working on a nice job, right? So, it's like, what, if we can rewind the clock to Bob a few years ago, maybe even younger, wherever you think you can stop, and tell us, how did you make it to the point? How did you make it to the point where something like writing, crafting interpreters became an idea?
Man, my career path doesn't make any sense. I'm a college dropout. I never took...
Me too.
Yay, high five.
Yeah, here you go.
I never took a compilers class in college before I dropped out. I don't like to brag a lot, but my book is currently the #1 selling compiler book.
Woo!
I have never taken a compiler class. I just got really, really lucky. My career path is kind of a random walk, and I just happened to stumble into the right stuff at the right time. I used to be a computer animator. I did UI design and pixel art for a while, and then I was a game programmer at EA for a while. I randomly left the game industry and got a job at Google because of a throwaway account I created on Reddit, and then like about a year later, I sort of finagled my way onto this brand new team that was making a new programming language, and none of it makes sense. There's nothing actionable there. I don't know. I just got super into, I got into game programming because I just got, really into trying to make games in my free time, and then, managed to get a job. And then I got super into programming languages as a hobby on paternity leave. When my daughter was born, she was born a few weeks early, and she was getting up at night a lot. And my wife and I kind of stumbled onto a system where I was like, I'll just be nocturnal. I will just do all the night feedings. I'll be a vampire, and then she will take care of the baby during the day. So I had all this time between feedings at night with nothing going on, and I was like, well, I'm interested in this language F#. So I got a book on F#, and I was like, I need some program to write in it. And it's like, well, F# has Lex and Yak built into it. And I was like, I'll try to make a little programming language. And it turns out it's like the funnest thing ever. And then I just kept doing it. And then eventually somehow stumbled my way onto a job doing it at Google. And then, yeah, it doesn't make a lot of sense. I don't know. I just think programming languages are awesome.
And then the book, though, was it because you found it fun?
Yes.
To write compilers, and
I don't find writing books fun though.
Yeah, that's fair. Is writing books? Is it the book you wish you had when you were learning compilers?
Yeah, that's
that kind
part
of
it. There's definitely, it was a struggle for me to learn this stuff because I didn't, take these classes in college.
Right, no formal education.
No formal education, and even more so, none of when you take that stuff in college, and especially if you do, a master's or a PhD in PL stuff, there's also just a ton of tribal knowledge you absorb, a lot of culture from being around those people that doesn't get written down.
Kind of like osmosis.
Yeah. And I didn't pick up on any of that stuff. So learning it was pretty hard for me. So part of it was like, yeah, I wish this book existed. Part of it is just, for whatever reason, the way I'm wired, if I get super excited about something, I'm like, I need to tell other people about this.
Right.
I'm very sort of Hermione Granger in that way.
Yeah. Me too.
I don't know. It's one of those things where it felt weird that, so I thought about writing a book for a while, and then I started writing the code for the book first. So there's two implementations of the same programming language. And, I had to design the language for the book and then work on these two implementations. And I sort of tinkered on it for a while.
Did you design locks as well?
Mm-hmm.
The grammar?
Yeah, whole thing.
The whole thing. So, okay, so you design a language, locks.
Yeah.
That's the one used in the books, LOX. Yes. Okay. And then you said, I'm going to write an interpreter for that in one language.
Yeah.
And then again in
and
another
bytecode
language.
VM in C.
Twice.
Yes. At some point, I thought this was going to be
Say those languages again. Which two?
Java and C.
Java first, and then C. Interesting.
Yeah.
Why? So Java runs on a VM itself.
Yeah.
So you're writing a VM for a VM.
Which is basically why I use Java for the first version of it, because it means when you're just learning the basic concepts, like how do you write a parser, like what is a token, what is a grammar, as you're writing the code for that, you don't have to worry about all the stuff that the JVM gives you for free. You get garbage collection, you get an object representation, you can just start making AST nodes and doing tree walk interpretation. So the first one is sort of high level because of that, and then once we get through that, and it's like, okay, let's see how the JVM does that, and it's like, now we're going to write an actual object representation, and we're going to write a GC from scratch, and bytecode dispatch and all that.
Can you define tree walk interpreter for folks?
Good question. Can I define tree walk interpreter? So the classic way to implement a programming language is language has a grammar. That grammar has a tree structure, just like every spoken language. If you ever did sentence diagramming in English, it's that, right? Where you have subject, and then programming languages also have that grammar. It is tree structured. So usually the first thing a language implementation does is it takes your source code and it parses it into a tree, an object that represents that nesting structure. A full-fledged compiler then takes that tree, converts it to other intermediate representations, and eventually generates machine code from it and lowers it all back down. But the simplest way to get a language up and running is you take that tree and then you just traverse it and do the runtime behavior of each piece of the language syntax as you reach it. So you walk into an if statement and then you're like, okay, evaluate the condition. If the condition's true, evaluate the then branch.
Is that skipping code gen of all kinds?
Skipping code gen, yeah. So you just sidestep it entirely.
Nice.
Which is a really simple, easy way to get a language up and running. It tends to be slow, which is why most industrial languages don't work that way. But for, if you're doing, not a general purpose programming language, but just like, a declarative language or a config file format or something, then just parsing to a tree and walking a tree is like totally fine, right? That's a totally reasonable way to do it.
And before I continue, people who do have access to the chat server, right? You could type in on the main room, because just to let the audience know, the main room is where we have the official discussion of anything you want to talk about, right? While you see the presentations. If you have a question for Bob, you can do Q : and then your question. So Q : ask your question, and then I'll take a look, see if we can answer them later. So if you have anything you want to mention to Bob.
I've requested that Abner ask me the most embarrassing questions.
Yes, absolutely. So have at it. So on the first half of your book, you say, okay, we have this language. We're going to learn how to write a compiler or an interpreter for this language. You do it in a simpler ecosystem, like the Java virtual machine. You do it in Java. And then on top of that, it's a tree walk interpreter. So it's like you're taking away all of the minutia required to manage this.
Yeah, so you don't really have to think about a back end. And it's a good time to learn just the high level concepts of like, what is, how to think about it is like learning sort of the software architecture of a compiler versus the kind of lower level implementation details of a compiler.
So part 2 switches away from Java to?
So part 2 is, okay, now we're going to do the whole thing again from scratch, but now we're going to do it in C, which gives you nothing. Because
in vanilla C? Just C?
Just straight C, yeah.
Nice. Okay.
And no third-party libraries, no compilers, no external tooling, nothing. Partially maybe because I'm a masochist, but also I sort of touched on this earlier. There's the psychological reason I wrote this book is I want people to come away from this feeling that things that feel unapproachable can be approachable. Because programming languages felt unapproachable to me for a long time. I was interested in them for a very long time, but I was like, no, that's for really smart people that went to college for it, and like I'm not one of those kind of people, so I can't do it. And then it turns out that is bullshit, and there's nothing special to it. So the conceit of the book is, well, I'm going to show you every single line of code, and therefore it must be approachable because there can't be any magic hiding anywhere. So it doesn't delegate to any libraries or tools or anything. It's just like we're just going to build a thing from scratch in C starting at main, which turns out you can actually do too. It's not a ton of code to write a VM, right? So the language locks is a fairly full-featured language. It has a fairly rich statement and expression grammar. It's got operators, all the different precedence levels. It's dynamically typed. It's got classes, inheritance, closures, anonymous functions, lexical closures, all that stuff. And you can build a CVM for that in, I think it's around 2,000 lines of code, which is for C, not a lot, right?
Yeah, no, that's amazing. And I would say for C, how do you deal with when you're building the interpreter for this, there has to be lower level management, which would include how to parcel out the memory blocks as you're maybe walking the tree. How do you allocate those memory resources? And let's start there actually. So let's talk about how you manage memory for your interpreter in C.
Yeah,
what did you do?
That's a good question. So there's two pieces of this, right? There's how do we manage memory for the language being interpreted, right? Yeah. Because LOX has its own memory management system. And then how does the implementation of the interpreter and compiler manage the memory it needs during that process, right? So for the latter question first, so how does the C implementation of LOX deal with managing its own memory? It tries to not allocate a lot. Part of the way that I keep the VM relatively small and simple is that it is designed to not create a lot of data structures and then throw them away. So it does not parse to a tree. It doesn't build this entire AST in memory. It walks your source code once and it generates bytecode as it goes. So there's very many fewer intermediate data structures in memory needed. Yep. And then for the few that it has, there's a couple of hash tables. They're just
trusty hash tables, of course.
Yeah, which you build from scratch because there's nothing in C, right? For that, there's a couple of functions for adding and removing stuff from the hash table and freeing the hash table, and then it's just manually managed under the hood for that. And it ends up not being a huge deal at the scale of LOX, which is just a couple of thousand lines of a VM, right? I probably wouldn't enjoy writing 100,000 lines of C code in that way.
No.
And then for LOX itself, because the language you're interpreting is garbage collected, you write a garbage collector from scratch.
So you do, okay. So you also teach people how to write their own garbage collector?
Yep.
Mark and sweep or what's
Mark and sweep, yeah.
Mark and sweep, wow. Okay.
Which is not as bad as it sounds, right? Like it's one of those things where like writing a GC seems scary, and
It does.
it's
to many
not.
people.
Like it's the mark sweep algorithm is like very straightforward. It's like you have a set of objects that objects in the languages world that you know about, stuff that is like on the stack in the language or global variables, and you walk them all, and then for every object you say, okay, well, what does that object have a reference to? And you walk those, and you just traverse that graph. It's just like if you can walk a tree in code, it is that. And then every time you reach an object, you mark it, and you say, okay, well, that one is potentially usable. It's still alive. So you mark it, and you say, I can't delete that one. And you just walk the graph of every object you can get to. And then after that, under the hood, the VM has kept track of every object it is allocated. Then you just walk that list of objects, and you say, are you not marked? Okay, I didn't get to you. Therefore, nothing in the program being interpreted can get to you, and you delete it, and you're done. And that's it. That is mark sweep right there. It's that, right?
The one on the C interpreter, the second half of the book, you do a pass in order to do code gen to target the VM, because you're writing a VM now, so you're going to target bytecode, I guess. So you generate bytecode at some point.
And then you have a bytecode interpreter.
Okay, so you have some user here, they're writing in locks, right? And then they run, is it like Python in its command line interface? Like just like
Basically, yeah. You just run it and you give it a path to a script to run.
Okay, and so their lock script compiles down to bytecode first before it then goes to the
And all this happens internally. You don't see it the same way you run Python or Ruby, right? It just
so you do teach people about bytecode and how to write their own. How do you design bytecode instructions and all of that? Do you discuss?
A little bit. That's a piece of languages that is kind of a subtle art, because it's like anything where there's a lot of interesting trade-offs, and designing a good bytecode instruction format can be, it's one of those things that language implementers spend a lot of time tuning and tweaking. The bytecode VM we do for locks is really simple. It's stack-based, mainly because that makes things easier for the compiler. And the instruction set, the set of instructions that each bytecode operand represents, or bytecode instruction represents, are basically one-to-one to fundamental pieces of language syntax. Each kind of operator has its own bytecode instruction. And then control flow ends up getting compiled down to go-to, jumps effectively. But that's about it. One way to think of, when you think of a bytecode VM, I think we tend to think of it bottom up, where we think of it as like, oh, this is sort of like an emulation of a fictional CPU. And that's a valid way to think about bytecode. Another way to think about it is looking at it from the top down of, I've parsed this program and I need a representation of the structure of the program. And you don't want to do a tree, a big AST, because that's complicated. There's a lot of pointer indirections, which is slow. Another way to think of bytecode is it's just a compact serialization of the tree structure of the program, right? And it's one that you happen to be able to interpret fairly efficiently. So you can kind of think of it as somewhere between those two. It's kind of a little bit of both, right?
So it's mostly you're translating one representation to another form of representation that is more compact, so that it, I guess, executes more efficiently.
Exactly.
Interesting.
Okay. And if you think about compiler pipelines in general, basically that is what they do. A full-featured industrial level compiler has lots of passes and optimizations. And basically what you're doing is you're taking it in one format and you're transforming it into a format that makes it easier for the next stage to work on. And you just keep doing that until eventually you run out of stages, and then you hit either what you're going to interpret, or you hit machine code and you're done, right?
Yeah, for sure. That's super interesting. If somebody reads your book and now knows how to write interpreters and VMs, would they then be able to take on like LOVM and replace it entirely? Is that there? No, let me tell you something. There's we have
within weeks.
We have one booth today. When you go have lunch and enjoy yourself upstairs, we have one booth from one dude. I don't know if he's here. He's like, I don't want to call you out. Sorry. But he's like 19, and he's like, I want to take on LOVM. He thinks LOVM is too entrenched and complicated and loaded.
I wish I still had that courage and energy.
The fierceness of it is one of the reasons we brought him here and said, like, let's just show your stuff.
That's amazing.
Because I wasn't that smart at that age. Like at 19, knowing how to write.
I'm still not that smart.
He's writing
definitely wasn't that.
He already has a usable C11 compiler, right? And he's like, LOVM is like, it doesn't. Why are we gatekeeping? Compiler backends. I can write my own and make it simpler and more accessible. And he's fierce. So he's here. He's like 19. I'm like, wow. It's like maybe he should be running the conference. And I should. take a step
Yeah,
back.
be glad he's taking on LLVM and not Handmade Seattle.
So, well, I do hope you talk to him. Like I believe he's a fan of crafting interpreters, so that could be cool. All right, so we're actually almost done here. That's really quick. If you do have questions, Q colon on the main room, and I'll scroll and see if I can ask something. But I'm not done with you yet. So before we finish, I'll say it again. So we have hot topics around memory safety this year. Okay, we have had public figures, and I'm not going to name names, right? I don't think
I can tell you're thinking.
They don't deserve the spotlight anyway. So where they say something, it's an indie conference, I can say what I want, right?
Yeah,
so it's they said something like a language like blah, which is memory unsafe, should not exist, right? Like I'll leave that. If you want to figure it out on the chat server who I'm talking about, it's like a highly public figure, defender of some language that is quite memory safe as they claim, right? And then they say that other language, that other community over there that is growing and becoming more interesting, is unsafe right now, doesn't deserve to exist.
Yeah.
Right? And then that just, stop, don't say the name. So on Hacker News, right, and again on social media, it could be a function of social media, right? I'm not trying to particularly pin it down, like there are incentives around here, but it's like, then that becomes explosive, right? Yeah. It's like this thing about memory safety versus memory unsafe, right? We have lots of low-level programmers here who still have to use vanilla C, for example, and who are now constantly getting barraged and criticized for not switching to, say, Rust, for example. And I'm sure there's, just so people know I'm not 100% biased, we have one demo that uses Rust upstairs, right? So it's not like, I'm not hating on any specific language, but I am.
But you're not hating on anything. I don't even know where I'm going with that.
What's your take on the whole memory safety fiasco online?
So there's two levels to that. So there's what is my take on memory safety, which is like an interesting technical discussion, but maybe not that interesting. And there's the question of like, why do people act the way they do?
Yes. Tell me.
Because we're just a tribal primate species. That is like the Intel architecture that everything else we do is running on top of, is the fact that we are just bands of monkeys. And, I think part of why people like us got into computers is maybe to escape that sensation and to feel like I can live in a world of pure reason and logic and stuff like that. But like, this is a very leaky abstraction, right? And, people, I try not to give into my primitive, tribal great ape impulses. But, we all do at some point in time, and, we get tribal about the stuff we believe in, we attach it to our identity, we think about...
attaching it to the identity.
Yeah.
I mean, that happens with Vim and Emacs as well.
It happens with everything. This is like 100% how human primates behave, right? It's just like
You're
whatever
saying it's an
we spend
unsolved
time
problem.
in becomes me.
It's an unsolved problem in computer and human science.
Yeah.
Okay. So we're done. We can't talk about it anymore. I think that's unfortunate. Okay. Let's.
I mean, we can keep talking about it, but
no, it's all good. So I'm gonna see if somebody has mentioned anything on the chat server here. I appreciate the banter. I appreciate the discussion.
But so I will say that. So I don't agree with people shitting on other people's stuff because they're like, oh, you shouldn't use this language because it's not memory safe. Like I try to be kind when I interact with people. But I also try to remember that like a lot of times, even when people are being angry and crappy, they shouldn't do that, but they are generally doing it from a position of trying to be good, right? Like if someone is saying memory unsafe languages shouldn't exist, they're not thinking about, I hate the fact that you learned this language and I want to invalidate all the time you spent learning it. What they're thinking about is like, I hate that security bugs happen and harm real people, right? Like they're coming at this from a perspective of like trying to make the world better. There's just a disagreement about which path to make the world better, right? So I try not to like think of them as bad actors, just people have different perspectives on it.
That's a more healthy point of view that maybe I should adopt, so I'm not like,
Yeah.
So I mean, let's give him a round of applause, folks. It's, Bob has chat server account, right? You're on the chat server, so people online, you can send him a ping. You'll eventually get to it.
Tell me how much you hate me, everything I'm doing wrong.
Absolutely.
I have a variety of languages that you can criticize.
I think you said hi in the introduction channel in the chat server, so you can scroll, find Bob, send him a ping, send him a
You can also talk to me in person if you'd like. But
if you're here in
not, that's okay
person,
too.
especially at lunchtime, come find Bob. Yeah, but we have 5 minutes left before the first official talk.
Okay.
Right? So let's
Are we gonna make it weird?
look at the look at the cues. Look at the cues. I should have brought chocolate wine. I really should have.
Yeah,
for you and me. Yeah. Let's see. Let's find a question here from.
Chocolate and wine is such a strange combination. Like
It's the best.
love them independently, but you know, it's like
So if you had Cabernet Sauvignon and then Dutch chocolate bar separate,
yes.
you're cool with that. But if I crush the chocolate bar into the wine and stir it and give it to you, you would say no?
I mean, I'm not saying I would say no. I'm just saying it is suspect. And I was thinking about this last night.
Channeling my inner chaos.
It's called Chocovine, right?
Yes.
I have a hypothesis that no food product whose name is a portmanteau is good. Right? Because that means that was a product that was created by like a marketing agency and not something that arose organically from someone who loves food. So I would try it, but
I need to vet my speakers better. One of the questions is from Tomas Diaz. He's asking, what part of writing a book did you not like?
all of the parts. What is wrong with me that I spent 6 years writing the book, and I had this weird obsessive trick that worked, which is that I worked on it every single day, and that was a thing.
Even Sunday, every day.
Every day. I mean, like, there was there's a brief gap in there when I finished the manuscript before I did the print edition. But basically, for 6 years, every single day, rain or shine, I worked on this damn thing, and I just obsessively did it. Right, like I hand drew all the illustrations in the book. I hand lettered every bit of text in every illustration. I did the page layout myself.
Sounds handmade to me.
By hand and InDesign. And like, God, it was hard. And it's like, I'm super glad that it's done now, and like it's really, really gratifying that people seem to like it and that it's adding value to people's lives. But man, it was work. Like,
yeah, I mean,
I don't know what I was thinking.
How many years was that again? Did you write it?
6.
6 years nonstop. Okay, I think that deserves another round of applause because
after I finished this, I told my therapist that I weaponized my perfectionism, which is probably the way to think about it.
Next question from Pal, P-A-L. Hello, Pal. We've seen some pretty broad topics covered by your books. First, game programming. Now, interpreters. What's the next big interesting area?
Man. People ask me that every now and then, and I feel like maybe this is obviously not an analogy that I can 100% relate to, but I feel like it's in the category of asking a woman who has just given birth, like, what kind of child are you having next? It's like, the labor process is done. I'm going to take a break from it. I don't have any plans to write a third book. The last one took a lot out of me, but maybe I will. And if I do, I have some ideas, but I'm not sure. It's I worked on this thing for every day of my life for 6 years, and then my previous book, I also worked on it every day for almost as long. And man, what a luxury it is to not be doing that right now. So I'm gonna enjoy that luxury for a while, and then.
Same with me on Friday after the conference.
Yes.
Like, I don't want to see you ever again.
Yes,
So,
exactly.
No, I love you guys. So one more question. I'm sorry, I'm seeing really interesting technical questions. We didn't have a chance to really dive into this, but again, he'll be around. Where you can go deeper with Bob here. So next question, how would you, this is from Rahit Awate. I'm so sorry for mispronouncing Rahit. How would you suggest a new grad to get a job in the programming language /compiler/VM space?
Yeah, every now and then people email me asking this, and like, I just don't have a good answer, because again, my career path makes no sense. So,
right, yeah.
It is the set of people working on general purpose languages is fairly small. It's a pretty small niche, but so it is kind of hard to get into, and it does seem to require a certain amount of chance.
Yeah,
but it's not impossible to get into, and there's a much larger surrounding field of software engineering and computer science that is like language adjacent, right? So people working on static analysis tools, people working on, you know, things that are like VMs, but are not VMs for programming languages, but are just, you know, other ways of representing data or executing logic. And that's a bigger world, and you kind of just, I don't know how people find their way to their jobs these days, because my career path didn't make any sense.
I'm gonna ask one more question. We have 2 minutes, so before the next talk. So, do you have any? This is from Scott Maddox. I think you're a regular. Thank you for attending the conference. Do you have any insights for efficient and effective error reporting? In my limited experience, error reporting seems to considerably complicate an interpreter.
It does. Yeah, so good error messages are really hard, and it is poorly served by the literature, right? Like you read all the compiler books and they don't cover this well. I tend to prefer writing recursive descent parsers, in part because it makes it easier to do good error handling, in that it gives you a place where you can insert the good error handling, but it is a metric ton of work, right? Like I've never seen a nice automated way to take all of the random wrong programs people will write and guide them back into what they intended to write. Like I've never seen a systematic way of doing that. You have to just, you know, so I work on the Dart team. We have a team of folks who write our parser and our static analyzer, and this is, you know, this is a fundamental part of their job, is just constantly taking, you know, looking at mistakes programmers write, looking at the error messages they report, and then trying to figure out, like, is that what they intended to do? What is a better error message here? And you just pour the engineering time in, right? It's effectively user experience design, right? And if you've ever done UX work, it's just work, right? Like humans are weird and strange and irrational, and making an interface to a strangely shaped human just takes a lot of iteration and time to get to something great. But I believe it's worth doing, right?
Absolutely.
I know that's not a super helpful answer, but...
Give him a round of applause one more time.
Thank you.